Hello, one more time, everybody. This is the last video you'll have to watch for me, and I will be back on Friday. So, last video to watch. It might be a little bit longer than the others, simply because trapezoids are pretty cool. They follow kind of a separate set of rules than parallelograms. Okay, they don't fall into the same category. Trapezoids are pretty neat. They're still quadrilaterals, right? We're still in the family of four-sided figures. Okay, still dealing with four-sided figures. All right, quadrilaterals. But trapezoids only have one pair of parallel sides. Okay, so like one of their, oops, I need to get the pin. There we go. One of their sides are parallel, and then the other two sides aren't. Okay. So that's the most common trapezoid you'll probably see, to where like the two sides are leaning in and you've got a short top and a longer bottom, or vice versa. Okay, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, now there's a couple special, there's one special trapezoid here that they mention is called a right trapezoid, and it's a trapezoid that contains a right angle as one of its base angles, which is funny because they haven't defined base angle yet, but it looks like this. You have a right angle, right? And then the top side's a little bit shorter and it comes down like that. Still four sides. That's a pretty terribly drawn one. Let's try this again. Let me try that one more time. Okay, right angle comes, I don't understand why that doesn't work. That's weird. Okay, right angle. This side comes up and then it meets. That's pretty close. Okay, so you've got a right trapezoid. Kind of looks like a van or something. I don't know. All right, now the bases. Okay, we have two bases. The two parallel sides. Okay, let's say we've got this, and it comes down like that, and that. We'll make that a little bit better. Okay, you've got your trapezoid. Our bases are this side and this side, the top and the bottom usually, but it's the parallel sides. Okay, those are called the bases. The legs are the non-parallel sides. So if I've got this and this right here is a leg, and this right here is a leg. Okay? All right. The base angles are the angles that are at the bases. Basically, all the angles in here are called base angles. Okay? So if you've got your trapezoid, I keep drawing them a little bit bigger each time because I've got more information to write. This angle, this angle, this angle, this angle, they're all base angles. Usually we refer to the bottom angles when we're talking about our base angles. That's usually what we mean by that, but technically they are all base angles because you have two bases. Okay. We're just going to jump into some of our examples here. Okay, they didn't tell us anything about the trapezoids as far as like consecutive angles being supplementary or anything like that, like they did with parallelograms. But if we have one set of parallel lines, think about this. Okay, think about this. If these are parallel lines, this line and this line right here appears to be a transversal. If you think way back to when we learned about parallel lines and transversals, that means this angle and this angle are same side interior. So same side interior. That means if we add them together, oops, try that again, that's a weird looking 3. Okay, if we add them together, they've got to add up to, that's right, 180. Okay, so we add our like terms. 12 and 13 makes 25x. 3 and 2 makes 5 equals 180. You subtract the 5, you get 25x equals 175. I would ask you how many quarters does it take to make $1.75, and you would say 7. So in this case, our x equals 7. Those two angles right there will add up to 180. Okay? Which, I want to tell you something, that's true all the time. Your two, your two angles, consecutive angles, this one and this one, okay, along the leg will add up to 180 because they are same side interior. Okay? Alright, let's keep going. I'm going to try not to make this video as long as it possibly could be. Okay. A median. Okay, a median is a segment that joins the midpoints of the legs of a trapezoid, and it's parallel to the bases. Okay, let's draw this. Let me draw you a picture of what this looks like. If I've got my trapezoid, I'm going to get pretty good at drawing trapezoids by the end of this, huh? Okay, if I've got my trapezoid, and I go up to the midpoint on each leg, let's say right here, I'm just kind of guessing at the moment, okay, right here and right here, and I draw the line that connects those. That red line right there is called the median. It is halfway up the trapezoid, halfway up the legs of the trapezoid, and it's parallel to the two bases, okay? All three lines here should be parallel. Okay? To find the length of the median, we use the following formula. We do base 1 plus base 2. Okay, that's the top base and the bottom base, or bottom base and top base, doesn't matter which one you do. And then you simply divide that by 2. Okay, let me rewrite this a little bit clearer. Hold on. Okay, let's do base 1 plus base 2. And we're going to use this line right here as our division line, divided by 2. Okay, it's basically finding the average of these two bases. Okay, that's what the median is here. We're basically finding the average of the two bases. The middle point, since you only have two bases, the midpoint, the median would also be the average. All right, so go on to the next page with me. Okay, so let's look at this example number 2 here. Okay. Pen, red. All right, we're good. All right, in trapezoid A, B, C, D, okay, so they're saying the trapezoid goes from A all the way to B, up to C, up to D, and back, okay? So it's the whole thing. EF is the median, okay? That means this is the midpoint of one leg, and this is the midpoint of the other. Find each of the following. So they say if AB is 25 and DC is 13, what is EF? Well, we just used that formula we just came up with, right? Base 1 plus base 2 plus base 2 divided by 2. 25 plus the 13, and then we're going to divide by 2. 25 and 13 makes 28. I'm sorry, 38. My bad. Makes 38, and we're going to divide that by 2 to get 19. Now, if you use a little bit of logical thinking here, doesn't it make sense that 19 would be halfway between 25 and 13? Okay, the median would be halfway between them. Okay, you'd have to go up 6 from 13 to get to 19. You have to go down 6 from 25 to get to 19. Okay, all right. So let's keep going. Let's see if we can answer the rest of these questions, even if we haven't necessarily talked about them before. Let's use our logical reasoning abilities. Okay. AE is 11. FB is 8. Okay. Think about point E and point F. Those are the midpoints of the two legs, right? The midpoint. So what would AD have to be? Well, if AE is 11, then E to D is also 11. So A all the way to D is 22. Apply the same thing over here on this right side. If BF is 8, then FC is 8. And 8 and 8 makes 16. Okay. In this next problem, letter C here, they say if AB is 29 and EF is 24, what is DC? Okay, that was supposed to be a question mark, and I think I failed at that. It's okay. What is DC? Well, if EF is the median, then it's halfway between 29 and whatever number it represents DC. So how did I get from 29 to 24? We went down 5, right? If I want to go from 24 down another 5 would make 19, right? So DC here is 19. Basically, I want 24 to be exactly halfway between the other two numbers. Okay? Okay, how about this? AB is 7y plus 6. Okay, AB is 7y. Ah, man, I'm not doing so well this time, huh? Let's try this again. 7y plus 6. EF is 5y minus 3. And DC is y minus 2. They want us to figure out y. Well, according to our formula, if we add this base right here and this base right here, and then divide by 2, it'll be equal to this one. Okay, so add them together. 7y and 1y is 8y. 6 and a negative 2, that makes a positive 4, right? We've got to divide that by 2 to equal the 5y minus 3. So we've got to do some simplifying before we start solving. 8y plus 4, all divided by 2. That means 8y divided by 2, 4y. And 4 divided by 2 makes it 2. Equals 5y minus 3. We start working at it. I'm going to move my 4y. I'm going to move my 3. And I get 5 equals 1y. So my y here equals 5. Okay. And last but not least, let's figure out E. Trapezoids have a lot of stuff going on, okay? There's a lot to think about with trapezoids, a lot to take into account. You got to take into account both their bases, their median, their base angles, all that stuff, okay? All right, in letter E, they say EAB, this one right here, EAB is 63. Sometimes my writing even upsets me. 63. Okay. They want to know what is DEF. This guy right here. Okay. Well, think about it. Parallel lines. Cut by a transversal right here. These are what we call this one and this one. They're corresponding angles which are congruent. So DEF would also be 63 degrees. Okay? Alright. And finally, example number 3. Okay? Remember, the bases are the parallel sides, right? The bases are the parallel sides, which means this is a base, and this is a base, and this is the median. Okay? So find the value of x. That's a median. So we're going to do 24 plus 34, and we're going to divide it by 2. That equals our x. 24 and 34 makes 58. Divided by 2 makes 29. So in this case, x equals 29. Okay, they finally give us a little table down here with the properties. Okay, there are basically two main properties to think about with all of our trapezoids. Okay, it has exactly one pair of parallel sides, and its median is found by adding the two bases and dividing by 2, or taking half of the two bases. Okay. I know it feels like I'm probably rushing. I just want to get through this with enough time for you guys to sit with each other and talk about trapezoids a little bit when I'm... Okay, now when it comes to trapezoids, you could have another special trapezoid. We talked about a right trapezoid where there was a right angle for one of its bases. Okay, we could also have an isosceles trapezoid. An isosceles trapezoid is just like what you think it is. Okay, like an isosceles triangle has the two legs are the same and the base angles are the same and all that. Same thing here. The trapezoid, an isosceles trapezoid, is a trapezoid with congruent legs. That means this side and this side are the same length. Okay? Still has all the other properties of a trapezoid. Okay, exactly one pair of parallel sides, the median. Okay, it just adds in the fact that the legs are congruent, then the diagonals are congruent, and the base angles are congruent. Okay, these guys are congruent, those guys are congruent. Okay, so lots of congruent pairs in an isosceles trapezoid. So let's see if we can apply this. Example 4 here. ABCD is an isosceles trapezoid. Decide whether each statement is true or false. Now see, I don't think these instructions are correct. I don't think these instructions are correct because they didn't give us a true or false. They asked us to figure out a measure. So these instructions don't make any sense. Sorry about that. I didn't write this up. Okay, these instructions don't make any sense. So instead of those instructions, how about we just find what they're looking for? We figure out the measure of the angle that they're looking for. All right, here they say ADC is 54 degrees. They want to know what BCD is. They want to know this guy. Well, in an isosceles trapezoid, okay, if we move up just a little bit to remember, an isosceles trapezoid, the base angles are congruent. Okay, this is a base angle, this is a base angle. So these two angles are congruent, which means if one of them is 54, the other one is 54. Ah. Oh well. Okay. Here they say if BAD, this guy right here, let's do this in blue, how about, so that we don't confuse ourselves. We'll do this one in blue. BAD is 112. They want to know what BCD would be. Well, they didn't tell us anything about opposite angles, did they? But what do we know about C and B? Don't they have to add up to 180? Aren't they consecutive angles, right? So they're same side interior. So if we can figure out angle B, then we should be able to figure out angle C, right? Okay, so if angle A is 112, then because it's isosceles, angle B is 112, right? And then these two have to add up to make 180. So I take 180 minus the 112 and leaves us with 68 degrees. Okay? Base angles are congruent. These guys are base angles as well. They're on the other base. They're on the top base, right? So if this is 112, this is 112. And then we remember that this side and this side, these two angles right here, are same side interior, so they're supplementary, which means 112 plus this guy had to make 180. We figured it out to be 68. Okay, let's see if I can't get rid of some of these here. Maybe not. Maybe. Who knows? Oh, I got rid of too much. Let's try this. 68. All right, one more. Letter C says if ABC, that's this guy right here, is 95, what is ADC? Well, this is just like the problem above it. This is just like letter B. If B is 95, then A is 95. And A and D here have to add up to 180. So 180 minus the 95 makes 85? Yeah. 85. Okay? All right. We are very close to being done. Okay? Very close to being done. Let's do the next page together. How funny. The name of this trapezoid is Done. Because we're almost done. All right. In example 5 here. It says DONE is an isosceles trapezoid, which means all those things in that table, all those properties are true. The legs are congruent, the base angles are congruent, and the diagonals are congruent. Okay? Now, it looks like we're talking about angles in this problem. Okay, I kind of get that from this little symbol right here. Sorry. This little symbol right here. Angles and the little degrees and all that. Okay, so let's go with the information. They say that EDO, that's this guy right here, is 110 degrees. They want to know what is DEN. Well, they don't want to know what DEN is. They want to know what X is. But what's the relationship between angle D and angle E here? They're same side interior, right? Because parallel lines cut by this transversal. Same side interior. Okay, so that means the 110 plus the 15x minus 5 has to equal 180. So let's do a couple things here. Let's put our 110 and our minus 5 together. So I've got 15x plus 105 equals 180. Now I've got 15x equals 75 by subtracting the 105 on both sides. And then we divide by our 15 to get x equals 5. Okay. Alright, last example. TRAP is an isosceles trapezoid. Okay, it's not saying that this is a trap. Okay, it's just naming the trapezoid. TRAP is an isosceles trapezoid. It says that PR is 3x minus 7 and TA is 20. Well, PR is this diagonal. TA is this. Wow, that was really awful. Let's try that again. Okay, sorry, I had to erase them both. Okay, let's try this again. PR is this diagonal. TA is this one. My goodness, I must be getting tired or something. Okay, if you look back on the previous pages, on the previous page, or maybe 2 pages ago, it gives us the information about isosceles trapezoids. Okay, what does it say about the diagonals? It says the diagonals are congruent. So, that means the 3x minus 7, which represents PR, is equal to the TA, which is 20. So we add 7, we get 3x equals 27, and finally x equals 9. Now, I know it probably feels like I rushed through these notes. I wanted you guys to get through this, have enough time to possibly work on anything you haven't finished from the past couple weeks. Tomorrow you will practice. You'll be given some practice problems on trapezoids. Use these notes. Watch the video on your own computer if you need to. If you need to go on YouTube and download the video or whatever, that's great. Have the videos. I've got them on a flash drive in my desk as well. So work on these. Talk these out with your little group members, okay, in your small groups. Talk out these notes. See if you can ask each other questions, bounce ideas off each other, and things like that. I will be back in a couple days. I am looking forward to seeing you guys and talking to you guys about my awesome trip. Thank you for all your hard work. Keep working hard, and I will see you guys on Friday.